In perspective, we can tell what is more close and what is more far away from us. One easy way to define this is size perspective. These balloons appear to be in different depths because they are different sized. When in perspective, we need to define what is our eye level. How tall are we? This is defined with the horizon line. That is the height where our eyes are. If there would be a person the same size than us standing on this scene, their eyes are on the same level, on the horizon line. Below the horizon line, we normally have the ground. If we have an even ground, it's easy to define how far away from us objects are. These squares are all touching the ground. I have indicated it with the shadow. We can now decide how far away they are by looking at their distance from the horizon line. The more far away the bottom of the box is from the horizon line, the closer they are to us. So this would be the closest, this would be the second close, and this would be the third. On the balloons, we don't know where they are compared to the ground. So we cannot define which is the most far away. They might be different sized. I'm now going to mark a shadow for each of them on the ground. If these would be the shadows, the balloons would be not in the order that I first presumed. This shadow is the most far away, this the middle, and this is the closest to the horizon line. That means that this is the closest, this is the second close, and this is the third close from the balloons. Because of this, we normally try to have similar sized same objects in the image. Otherwise, it can get confusing. I will now draw a few more people to the picture. On even ground, we can now easily see who is more far away and who is closer to us. A is the closest, B is the second one, and C is the most far away. But who is the tallest of these people? A, B, or C? For this we go back to the first guy. Eye level is the horizon line. So, person B would be my height. I am 188 tall. Then, person A. I don't know exactly how tall they are, but I can easily see that they are below the horizon line. For that reason, they need to be shorter than me. Then we have person C. Their eye level is above the horizon line. He needs to be taller than me. He is taller than me, more than 188, and this guy is shorter than me. So, defining what is more far away from the size, if we would know that these are the same sized. We can define who is more far away from the point they touch the ground, if the ground is even. For these, we define that with the shadows. Then, because the horizon line is our eye height, if we would be standing while drawing, I would see person B to be the same height as me. Person A's eyes are lower, so they need to be shorter than me. And person C's eyes are higher than the horizon line, they need to be taller than me. First we define where our eyes are, where we are looking at the scene. So where is the horizon line? Next we are gonna put some objects to our scene. One rectangle above the horizon line, one rectangle below the horizon line, and one rectangle crossing the horizon line. So, these are my rectangles. If A and B are touching the ground, I can see which one is more far away and which is more close. Of C, I don't know anything. Then, let's make these rectangles into boxes. For making them into cubic forms, we need to define a vanishing point. It's on the horizon line, normally in the middle of the image. Vanishing point. Now that we have the vanishing point, we can draw these into 3D shapes. All of the lines in one point perspective go either vertical or horizontal, or to the vanishing point. So, on B we have defined this side. Next we need to define the side of the box. This is done by drawing lines from the corners to the vanishing points. So on B, from here to here, and from here to here. Now we have a never-ending box vanishing to the vanishing points. We would also have lines behind here, behind the shape. So, what we can see now from the box, we can only see the side that is facing us and the side on the side. We cannot see the box's top or bottom. Then let's continue to box A. On box A, if we draw the lines from the corners to the vanishing points, it appears as so. From C to vanishing points, it goes as follows. So from all the corners to the vanishing points. You should also mark the other corners with the dots line. So now we have 3 never-ending boxes. On A, we can see the side, on the vanishing point side, and the top. On C, we can see the bottom and the side. So, for everything that is below the horizon line, we can see the top of. Everything that is above the horizon line, we can see the bottom of. Okay, then let's decide on depths for the boxes. You can freely decide how deep the box is. A vertical line there, and from the corner a horizontal line. I can define these as I please. So, now I have 3 boxes. Now we have drawn boxes, but what if I want to draw a cube? First off, I'll define a horizontal line and a vanishing point. Then I'm going to draw a cube. It has same height and same width in 1 point perspective. We are looking at this side straight from the same side. Then the edges go to the vanishing point. Then, when creating the first cube to the scene, I can now decide the depth. Whatever looks natural to us. So, that is a cube. The depth of the cube can be defined as I just did. I can now explain why. And for this I'm going to create a square grid to this perspective. I'm going to forget about this box. Now I'm going to define a new grid. And for this I'm going to start with a square, the bottom of a box. I will define it here. It will be 5 centimeters wide. Then when it's in perspective, I need to draw these lines to the vanishing points. Same then with the cube. I can now decide on the depth of the square. So this would be square A. I'll draw it here on the parallel projection. Square A. Then we're going to draw square B, which is next to square A. That is easy. I'll just check, okay, 5 centimeters wide. Now B will also be 5 centimeters wide. And it of course has the same depth than A. Okay, I have now decided on square B. I'll draw horizontal lines from square A to define few more squares. This would be square C. Okay, so this way I can decide all the squares next to each other. 5 centimeters, 5 centimeters, 5 centimeters, and to the vanishing points. Okay, so all of these are now defined. This bottom row. Then we need to decide on the next levels. Squares, for example, D and E. So the one coming here and one going here. These are defined by slicing the previous squares. Starting from corner to going through the other corner as follows. It's easy to understand this on the parallel projection. The line crossing A to corner also crosses D from corner to corner. So now we only need the line from the vanishing point and the line crossing from here. And now we can start defining on the depths on these two rows, the ones with E and D. And again, all the lines are horizontal or going to the vanishing point. So we have a line here. Crossing these. And then we have a line here starting from this crossing. And like this, we can continue on doing the grid. If we need new diagonal slices, we can just decide to cross any of the squares we have, like this. That's the same than doing the line here in perspective. Here you can see that the lines are getting all the time closer to each other when they go nearer to the horizon line. Now making these squares into boxes or cubes. 5 centimeters wide is as a cube is of course 5 centimeters tall. So we defined the height by measuring the bottom. This is easy in 1-point perspective. Then we follow the lines from the corners to the vanishing points. So this here is a cube. Ten and a half, or let's do it on this side. Now I'm going to draw another cube here on this square. Again, I'll check the new measurements. 10.5 centimeters wide means as a cube in 1-point perspective, 10.5 centimeters high. And all the lines horizontal or vertical or towards the vanishing points. So all of these are cubes. They are just distorted on different way on the perspective. And that's how you can just decide on the first cube. Cutting stuff in half in perspective. I'll define a horizon line and a vanishing point. If I have a parallel projection looking straight from the side or from above, it is easy to check what is the midpoint just by measuring the distance and marking the midpoint. But this method I cannot use in perspective. If I check, this would be 9 centimeters and this would be 4.5. That is not the center point of this form. Okay, an easy way to define a center point. Cross it. Draw a line from corner to corner and from the other corner to the other corner. In here, you can find the center point and draw a vertical line to cut it, or a horizontal one. This works also in perspective. From corner to corner and corner to corner. This is the center point of this form. If I need to have more points defined, for example a fourth, I can continue with this method. I'll just cut one of these again from corner to corner. I have now defined a fourth of this. This I can do in perspective, corner to corner, and a vertical line, and a line crossing the midpoint and towards the vanishing points. Then I can, if I want, cut this again in half by crossing it and define a new line and a new fourth. So, this is how you can define halfway points in perspective. I have a rectangle and I want even space next to a rectangle, then a new rectangle. Again, easy if I can measure 1.8, 1.8, 1.8. Again, in perspective, really hard. How to define these eighths? I need to cross these. First I need to slice this in half by crossing this box. In perspective, then cutting it halfway. Now I have this halfway point and this corner defined. With these 2 points, I can draw a straight line and I will end up in the corner of the next rectangle. In perspective, from here to here, I now know how far away the next rectangle is. Next I need to define how wide it is. Continue the halfway point, going to the next corner and drawing a line from corner to corner. So going from here to here and defining a line from this corner through this corner. That would be the next crossing. So, slicing, finding the halfway points, using the halfway points to count equal intervals.